Hi, welcome. This video is about how to solve a system of equations using an inverse and doing so by hand, meaning without technology. And again, just as a quick review, if we use capital A to represent a matrix times x, which in this case, because it's a two system equation with two variables, in this case, capital X would be the matrix that represents just x, little x and little y, the variables x and y. And then this is equal to B, which is the matrix on the other side, that the 2 by 1 matrix. And so the in order to get that x alone, which is generally what we want to do, we're solving an equation. We want to take our matrix and multiply it by its inverse, and do that on both sides. So the inverse of times b, these cancel each other, and then you're left with just x is equal to the inverse of a times b, and that'll give us our value of x and y when we're done. So we need to write our two matrices. We're going to say A equals the matrix 2, 5, and then 1 and 2, and B, our matrix, is equal to -2 and -3. So we need to find the inverse of A. You'll recall from an earlier video, if you watched it, that inverse of A is equal to 1 over the determinant of the value of if A is the matrix A, B, C, D, then the inverse of A is 1 over the determinant times, and these D and A switch places. B and C stay where they're at, but they become the negative B and negative C. And if you multiply those all out, multiply this 1 over the determinant kind of as a scalar, then the result will be the inverse of A. And so the determinant first of A is equal to 2 times 2. 2 times 2, that's A times D, minus 1 times 5. 1 times 5. And 2 times 2 is 4. 1 times 5 is 5, so minus 5. And 4 minus 5 is -1. And so the determinant of A is -1. So if I've got 1 divided by the -1, that's just -1. So what we're going to get then for our particular instance is that the inverse of A is -1 times our 2 switch places. They're still just 2. There's 2 and 2 switch places, still both 2. And then 5 and 1 stay where they're at, but they become negative. So -5 and -1. Now we go through and we multiply out the scalar -1 times that. We get -1 times 2 is -2. -1 times -1 is a +1. -1 times -5 is a +5. And then -1 times 2 is -2. And so that's our inverse. And so if we go back up here, this is what we're looking for. Our value x, our solution xy, is going to be what we get when we take A inverse times B. So we're going to take A inverse, or the inverse of A, times B. And what that looks like is we have A inverse, which is -2, 5, 1, and -2. And then we're going to multiply that by -2, -3. And just again, as a reminder, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. And it's because this number of columns on the first matrix is equal to this number of rows on the second matrix that we can do this multiplication. And as a result, what we're going to get is a 2 by 1 matrix. And that's what we want. It'll be our value of x and y. So to get that, our we'll call this row 1 and row 2, and this would be just column 1. We only have the one column. So I'm going to take this row 1 times that column, -2 times -2. I'm going to add that to 5 times -3. 5 times -3. And then for the bottom, I'm going to take row 2 for this is my new row 1 and this is my new row 2 here. And there's only going to be one column. It might look like more than that, but all of this is going to come into all of this right here is going to come into one number. And so then my bottom row, I take 1 times -2, 1 times -2, and I'm going to add that to -2 times -3. And then I just have to kind of simplify this out. -2 times -2 is a +4. And then 5 times -3, that'd be -15. And then on the bottom, 1 times -2 is -2, and -2 times -3 is a +6. And then just one more simplification takes us to 4 minus 15 is -11, and -2 plus 6 is 4. And so that is our solution, but just to make sure that you know how to interpret it, it's the ordered pair -11, comma 4, where -11 represents x and 4 represents y. And that's the solution that we get, -11, 4. And that's what we had. All right, thank you.